right? So let's, again, good morning, grade 9, my advisory.
Morning, sir.
Let's have now Science 9. And let's have a recap first. Diba we are talking about the valves yesterday, the last time. We are talking about the atrioventricular valves and the semilunar valves. What are those in atrioventricular valves? Atrioventricular means to say that it is in the center of ventricles. What are those valves? We have valves in the
Pulmonary
atrioventricular.
valve.
Pulmonary is in the semilunar. Atrioventricular means to say it's in the center of ventricles. We have the tricuspid valve, which is in between right atrium and right ventricle. Okay. And of course, the bicuspid valve or the mitral valve, which is in the center of left atrium and left ventricle. Okay. How about the two semilunar valves? Semilunar because it looks like a moon shape. Okay. We have, for the semilunar valves, we have
Pulmonary valve.
pulmonary valve, correct, which is in the center of right ventricle, okay, and pulmonary artery, okay, naa siya sa center, okay, and of course, the important one, which is the aortic valve, which is in the center of left ventricle and aorta, which is the largest artery in the body, okay. Again, the atrioventricular valve we will start with tricuspid. Tri means three. Tricuspid valve in between right atrium and right ventricle. Okay. And the bicuspid valve, bi means two, or mitral valve, which is in the center of left atrium and left ventricle. And of course, the two semilunar valves, which is in the center, the one being in the center of right atrium and pulmonary artery, which is the pulmonary valve. And the other one is the aortic valve, which is in the center of left ventricle and aorta, the largest artery in the body. I will teach you how to create a mind map out of it, right? Let me share my screen again. We'll use the whiteboard. Let me check if my whiteboard is still working. Okay. Diba? From the upper part of your body, blood will actually pass through superior vena cava. Okay? And from the lower part of your body, blood will pass through inferior vena cava. Superior vena cava and inferior vena cava. They're both entering the heart at the right atrium. Diba? Atrium means a place to stay. Okay, that's atrium. Just like your north atrium in SM. This is a place to stay. If you're going to observe, a lot of people are actually staying there. Okay, they're actually having a chat or doing something in their cell phones or listening to music because that is just a place to stay. Okay, atrium. From the right atrium, okay, again, superior vena cava and inferior vena cava, they will both entering the heart at the right atrium. From the right atrium, okay, it will pass through a valve because this is to prevent backflow of the blood. remember that the blood here is unoxygenated or carbaminohemoglobin. It contains carbon dioxide. So it should never be having a backflow, or else you'll be contaminated. Okay? You'll be poisoned with your own toxins. If that is the case. Okay, from the right atrium, it will pass to a valve called what? Tricuspid valve.
Ball.
Okay. Tricuspid valve. From the tricuspid valve, so pass na siya sa tricuspid valve going down to the what? Right
Ventricle.
ventricle. Because this is the pumping area. Remember that the work is actually hard here. That is why the walls are really thick. This is the purpose why we have a thick walls in the ventricles. Kay diha magpump og blood. Okay, this is the area for working. Okay? From the right ventricle, in order for the blood not to have a backflow, it will pass again to a valve. Okay? It is called a
Pulmonary valve.
pulmonary valve, correct? A pulmonary valve. And then to your, from the pulmonary valve, it will
The
go to
pulmonary artery.
pulmonary artery, correct? Pulmonary artery. Okay. This is now the pattern. We are now in the pulmonary artery. This is now going to your
To the lungs.
lungs. Okay. For exchange of gases. Remember that the exchange of gases happens in the lungs. The actual exchange of gases happens in the lungs. Okay. Any concerns? Questions? Yes, Hilary? Do you have any question? Okay, we are now in the lungs. So, yes, again? Hilary, I cannot hear you.
I said none, sir.
Okay, okay. So in the lungs, the actual exchange of gases happen from carbon dioxide to oxygen. Okay, from carbaminohemoglobin to oxyhemoglobin. So now your blood is carrying oxygen. This is the reason why your blood is colored red. In the absence of oxygen, it's colored blue. Okay, that is why there are a lot of blue babies. Okay, are you familiar with the blue babies? Okay, blue babies has less oxygen. That is why. So again, if there is an absence of oxygen in the blood, it is colored blue. Okay? Because there is oxygen reacts with iron. So that is why. So your hemoglobin is actually carrying iron. Now from the lungs, your blood is carrying oxygen now, or oxygenated blood, or oxyhemoglobin. Okay? It will return to the heart. Okay? The blood will return to the heart through what? The
To the
blood will
right
return to the heart
pulmonary.
through, diba atrium
The
is
right
an area
pulmonary valve. Oh,
no,
the left atrium.
the left atrium, but it will pass through a pulmonary vein.
Vein.
Okay. This is a tunnel, okay, or a passageway going to the left atrium. It is a tunnel going to the left atrium. Okay. All the oxygenated blood will actually return to the heart through pulmonary vein and to the left atrium. Okay. Now the oxygenated blood is in the left atrium. Right? From the left atrium, this should not have a backflow. So to prevent a backflow, we have what valve? bicuspid
Mitral.
valve or mitral. Bicuspid valve or mitral valve. So this is now to prevent the backflow from the left atrium going to the left ventricle. Because in the left ventricle, again, this is the pumping area. This is the working area. Okay. From the left ventricle, blood is pumped. Okay. But to prevent backflow again, it will pass through a valve again. Okay. A semilunar valve, because this is in between aorta and left ventricle. Okay. What is that valve? This is the
Aortic.
aortic valve. Okay. From the aortic valve, blood will go now to, because it is already pumped in the left ventricle, and it also prevents, the aortic valve prevents backflow. Blood will go now to aorta,
Aorta.
the largest artery in the body. Okay. From the aorta, blood will go now to the different parts of your body. Okay. From the different parts of your body, syempre it carries now, di ba? This is now carrying oxygen. So the oxygen is being transported to all parts of your body. And in exchange, okay, it carries the waste material of the body. The waste material of the respiration. Okay, what is the waste material of cellular respiration? Is carbon dioxide. Okay. The blood now is carrying carbon dioxide. It will return to the heart again via superior and inferior vena cava. The cycle repeats again and again. Okay. We have simultaneous circulation here. Okay. If you're going to observe from here, okay, pakitunta mo ha. If you're going to observe from here, okay, from here, and here. Okay. If you're going to observe that one, this is carrying carbon dioxide or carbaminohemoglobin, correct? And this one is carrying oxyhemoglobin. Correct? So since this is carrying carbaminohemoglobin going to the lungs, this is called pulmonary circulation. Pulmonary means lungs. Okay? And since this is carrying now oxygenated blood going to all parts of your body, okay, this is called systemic circulation. By the way, all parts of the body is included, okay? Systemic circulation. So this is now the two main circulations in the circulatory system. We have pulmonary circulation going to your lungs and systemic circulation going to all parts of your body. Okay? In pulmonary circulation, the blood is carrying carbon dioxide or carbaminohemoglobin. And In the systemic circulation, the blood is carrying oxyhemoglobin or oxygenated blood or oxygen carrying blood. Okay? Did you get the point? This is concept mapping. Okay? I am just imagining the blood flow, where the blood will go actually. Is that easy?
Yes.
What do you think? How about other students? Is that easy? So this is now, if you're going to look at it, you can actually see, okay, the blood flow. This is now blood tracing. You'll be doing this one also in your activities after the discussions. Okay? Do you have any questions so far?
No, sir.
There is a question there that you're asked to trace blood, which the blood exits from the valve going to the right ventricle. Okay, so you will start at the valve going to the right ventricle. You're asked to start at the valve going to the right ventricle. So in the tracing, because it is numbered, the tracing there is numbered. Like for example, you're asked to the valve going to the right ventricle. So this is number 1, tricuspid, number 2, and so on. So you'll be numbering it, okay, based on the sequence of the circulation from the pulmonary circulation going to systemic circulation. Right? Do you have any questions so far? Do I need to repeat this one?
No, sir.
No need na? How about others? Should I repeat this one? The process?
Sir, the carbaminohemoglobin, where does it belong? Does it only belong to the lungs?
Yes. Carbaminohemoglobin,
Um,
meaning to say it carries carbon dioxide.
How about the pulmonary circulation, the lungs and the PV1?
No. Pulmonary circulation is actually blood going to the lungs. Okay, that is the
Okay.
pulmonary circulation. This is separated, by the way. This is separated. Okay, this is separated. Okay. Pulmonary circulation, meaning to say the blood is actually going to the lungs for exchange of gases because it carries carbon dioxide or carbaminohemoglobin. Okay.
The
Yeah.
oxyhemoglobin.
Oxyhemoglobin, if you're going to observe, diba, from the lungs, okay, there is the actual exchange of gases through your alveoli at the end point of these lungs. From the lungs, the actual exchange of gases from carbon dioxide to oxygen happens. And it will actually transported back to the heart. So when the blood returns to the heart, it will start the systemic circulation. Okay.
Thank you, sir.
Once the blood is oxygenated and returns to the heart, it will now start the systemic circulation. Okay. Any other question? I like that question, Julian. Thank you. Any other question? Okay.
No more, sir.
All right. Again, pulmonary circulation happens when the unoxygenated blood or carbon dioxide carrying blood or carbaminohemoglobin will actually go to the lungs for the actual exchange of gases. That is actually the pulmonary circulation. Pulmonary means lungs. Pulmo. Okay? Pulmo. That's in the lungs. Okay? After which the blood will return to the heart. Okay? Once the blood returns to the heart, it will now start the systemic circulation. Okay? Because it is now carrying oxygenated blood or oxyhemoglobin. Okay. The purpose why we need to have systemic circulation in order for the blood to transport the oxygen it carries to the all parts of the body or to the parts of your body. Okay? And remember that this is really important. Why? Just a single minute or 60 seconds without oxygen, your brain will eventually die. You'll be in coma. Just single minute or 60 seconds. 60 seconds lang ha, and you'll be in coma or comatose. That's how important this cycle is, or this systemic circulation is. We're using oxygen because we are aerobic organism. Aerobic means we use oxygen for cellular respiration. Okay, without oxygen, your brain will die, and even your system will go down. All your systems will stop working. This is how important oxygen is. That is why, as what I have observed here, in this pandemic situation, they tend to collect a lot of oxygen tanks in their houses without knowing that if you will store oxygen, okay, it will actually create water. Okay, and it can also be a toxin, or it can be toxic to us if it is not calibrated. That is why it should be calibrated. That's the reason. Okay. So again, if you don't need oxygen, please do not store it at home. Okay. We have a lot of oxygen suppliers here, so no worries. But we still don't need them. Okay. How can you check your oxygen level? By using pulse oximeter. Okay. Pulse oxy, the one that I had shared to you last meeting, the one that you will actually put in your fingers to check on your oxygen level or your auto saturation. Okay, those are pulse oximeter. So those are important medical equipment also to check the oxygen level. Below 95%, remember, below 95%, you need to supply your body with oxygen through nasal cannula. The one we put on the nose. Okay, those are called nasal cannula. But if you don't need oxygen, no, do not store oxygen. It can be toxic. Okay. Again, it will just transform itself into water. Remember, water is composed of hydrogen and oxygen, and hydrogen is everywhere. Okay. Once it binds with hydrogen, it will create water, and then it will become toxic. Right? I think we only have 3 minutes left, and we discussed a lot. Hopefully, you learned something out of this simple illustration, because we'll be doing also this one. As what you had observed, the one I had sent in your GC, those was actually done by my previous students. Okay, they have blood tracing using the actual heart. Okay, their dissected heart. They dissected the heart actually. Okay, they're the one doing it. I'm just guiding them on what to do. Right? I think that will be all for today, class. I prepared an activity for you in your LMS. Please do activity number 2. Let me stop my sharing first. Please do activity number 2 in your LMS. The conceptualization. Okay. And hopefully I can get answers from you, brilliant answers from you, right? These are concepts we had just discussed, okay? I just need to see if you really get the lesson, okay? These are just concepts, right? And you just give me your insights about these concepts. Okay? Question so far?
Excuse me, sir.
Yes, Hillary.
When is the activity due?
This will do this Friday. I, diba, in our previous school year, Hillary, I'm just giving you around 1 day man ata to. Tama ba? Around 5 p.m. man to, no? In the previous years, every day. Now, you have man your um independent learning in Friday. So I usually put it in Friday at 5 p.m. So it will be uh due this September 3 at 5 p.m. So at least you can also do the other tasks assigned to you by your teachers. Okay, again, I am always considerate with my advisory. That's how biased I am with my advisory. That is why. So this will do on September 3, 5 p.m. Okay? No worries, take your time.
Okay, sir.
Take your time answering, right? Janine, how are you? Are we okay there? That's good. Okay, I think that will be all for today, class. Thank you for your participation, mga anak. Have a nice day. Take care, everyone. Hope to see you soon.
Bye.
Bye.
Bye-bye, sir.
Bye-bye.
Bye.
Bye, sir.